As we get ready for the hands-on part of our CAPI SNAP education, let's take a look at the checklist of items we will need. For the development portion of our work with CAPI SNAP, all of the items listed here come in the CAPI SNAP Developer Toolkit and can be found in the GitHub repository. This includes the CAPI SNAP infrastructure written in RTL, the power service layer for communicating with the power processor, the Xilinx FPGA toolset called Vivado, which will compile your action code for the FPGA, a set of example libraries which you can use as a base, and the CAPI simulation engine, which you use to validate your code before running it on the hardware. When combined with your action code, the output of the development process is a bit file image that loads onto the FPGA, along with your host side application that calls the accelerated action. For deployment, we combine the power hardware and FPGA card, the bit file image from the development phase, and the host library and application. These components come together to create the accelerated solution.
Today, Snap supports CAPI 1.0 on Power 8. The whole design is based on standard XC interfaces. So this allows us to replace the data movement engine without changing the actual interface. Therefore, the interface for the developer doesn't change when we change from CAPI 1.0 to CAPI 2.0 to OpenCAPI.
A few forward-looking statements about Snap on Power 9. IBM and the Open Power community are already working on CAPI Snap cards and infrastructure that take advantage of Power 9's acceleration capabilities. These features include the additional bandwidth and lower latency of both PCIe Gen 4 and OpenCAPI, which have maximum bandwidths of 16 gigabytes per second and 25 gigabytes per second, respectively. But we also have more area for your actions, as well as flexible timing constraints. With Power 9, we've added further performance enhancements, like thread wake-up, which enables the action on the FPGA to perform work and then wake up the requesting thread when ready. This innovation saves the core from having to spin on interrupts or poll for results. So as you develop actions on Power 8 infrastructure, rest assured that all of your work will carry forward to the next generation and take advantage of the improved performance. The CAPI Snap development and deployment processes have many parallels to software development. With application code, you first start planning your modules before creating your initial version of the code. When ready, you'll take your code through a compiler step and start your debug and testing phase. At that point, you may loop back to the code creation phase to make fixes and performance improvements. Finally, when your code has passed all of your functional tests and meet performance requirements, you can deploy it. Our CAPI Snap process follows the same steps of plan, create, compile, test, and deploy. For our class, we break the steps into two parts, separating the planning phase from create, compile, test, and deploy. This chart shows the full process, with the preparation phase on the left and the execution phase on the right. As we walk through the next modules in the series, we will refer back to these process steps as a "You Are Here" guide to the overall process. Our next module starts the prep phase and will walk through the 4 steps shown in the flow on the left.